Something unusual is happening in mathematics. For centuries, mathematics moved at a human pace. Ideas were written by hand, debated in letters, refined over years, sometimes over lifetimes. A theorem could take decades to prove. Entire careers were built on one breakthrough. But now, in 2026, something has shifted. Artificial intelligence is no longer just assisting with calculations. It is entering the territory of conjecture, proof, and discovery. And that changes everything. In the last year, we have seen AI systems scan vast mathematical literature in seconds, identify overlooked lemmas, suggest proof strategies, detect counterexamples, and even propose new lines of reasoning, not perfectly, not flawlessly, but convincingly enough to make the global mathematics community pause. Some call it hype, others call it a turning point. Either way, the conversation has changed. AI is no longer just a computational tool. It is becoming a mathematical collaborator. At first, excitement dominated headlines. Claims emerged that AI had solved long-standing open problems. Social media exploded. Was this the end of slow, human-driven proof? Was mathematics about to become automated? But as researchers examined these breakthroughs more carefully, reality proved more nuanced. In several cases, AI had rediscovered known proofs buried in obscure papers. In others, it generated arguments that looked elegant but contained subtle logical gaps. It was not magic, it was pattern mastery at scale, and yet, that alone is revolutionary. Mathematics has always depended on memory, remembering theorems, techniques, analogies. AI now possesses a form of expanded mathematical memory far beyond any individual human. It can search, compare, and synthesize thousands of papers almost instantly. In a sense, it compresses centuries of scholarship into seconds of computation. That changes the research workflow fundamentally. The hardest part of many mathematical problems is not the final step. It is knowing which existing tools to apply. AI excels precisely at that. But does this mean mathematics will become commoditized? Will anyone with access to AI be able to do professional-level mathematics? Not yet. Current models still struggle with deep logical consistency. They may propose a convincing proof, but invert an inequality sign or assume something unproven. They can mimic reasoning, but sometimes lack the internal coherence required for airtight mathematics. At present, AI is better described as a discovery accelerator rather than a replacement thinker. However, history teaches us that tools reshape disciplines. When calculators became widespread, basic arithmetic skills changed. When computer algebra systems emerged, symbolic manipulation evolved. Now AI threatens to reshape the creative layer of mathematics. If machines can suggest conjectures, test examples, and outline proof structures, what becomes the role of the mathematician? The answer may not be elimination, but elevation. Humans may shift from mechanical derivation toward conceptual framing, from solving problems step by step to asking deeper questions about which problems matter. This is not only about mathematics. The AI maths revolution signals something broader. Mathematical thinking underlies physics, cryptography, economics, machine learning, engineering. If AI accelerates mathematics, it indirectly accelerates every discipline built upon it. Faster theorem discovery could mean faster advances in materials science. More efficient optimization techniques could improve energy systems. Better probabilistic modeling could refine medicine. Mathematics is infrastructure, and AI is upgrading that infrastructure. But there is another side to this revolution: intellectual responsibility. Mathematics demands rigor. Proof is sacred. A result is either correct or it is not. If AI-generated mathematics becomes common, verification will become even more critical. Mathematicians may increasingly act as validators, ensuring that machine-generated arguments hold under strict scrutiny. The partnership between human skepticism and machine creativity may define this new era. Some fear obsolescence, but perhaps the deeper transformation is skill redistribution. In the past, mathematicians needed vast memory and technical endurance. In the future, they may need stronger judgment, abstraction, and conceptual clarity. AI can explore, humans must interpret. AI can suggest, humans must decide significance. The revolution is not the disappearance of mathematicians, but the redefinition of what mathematical expertise means. It is also important to recognize the psychological shift. For centuries, mathematics was seen as the pinnacle of uniquely human reasoning. The idea that a machine could meaningfully contribute to theorem discovery feels almost existential. But we have been here before. When computers first proved the four-color theorem, Debates erupted about whether a computer-assisted proof was real mathematics. Today, such proofs are accepted. The boundary of what counts as legitimate mathematical work evolves with technology. We stand at a similar boundary now. The AI maths revolution is not a single event. It is a process. At present, AI is an extraordinary research assistant. In the near future, it may become a co-author. Eventually, it may autonomously explore abstract structures beyond immediate human intuition. Whether that future arrives in 5 years or 20 remains uncertain, but the trajectory is clear. The relationship between mathematics and intelligence is being redefined. For students and researchers in 2026, the message is simple. Ignoring AI is not an option. Understanding it is essential. Those who learn to collaborate with AI will amplify their productivity. Those who resist it may find themselves limited. The revolution is not about surrendering creativity. It is about augmenting it. Mathematics has always evolved with tools. From abacuses to symbolic notation to computers, AI is the next tool. But unlike previous tools, this one thinks in patterns. And that makes it different. The AI maths revolution has begun. It is messy. It is controversial. It is imperfect. But it is real. And like every revolution in intellectual history, it will not simply change what we calculate. It will change how we think.